Welcome back to the Foundation in C# course. We are currently in Module 9. In this lesson, we're going to be wiring up Dapper, or setting up Dapper in our application. So, your homework? Add a Dapper class that will handle reading from and writing to SQL different for you. It's probably a minor version, and if so, go ahead and install the latest version. If it's a major version, then you might want to see what breaking changes there are. A major version is the first number. So you might have to roll back to this version if it's some breaking changes, but probably it'll be pretty stable, so you won't have to worry about it. All right, so we've got Dapper installed. And now we can add a using statement at the top using Dapper. And let's add a using statement for system.link. We'll need that as well. Okay, let's create first a method that's going to load data. So public list of type T, that's going to return load data. We're going to pass in T and U. These are generics. So if you don't remember generics, I believe it's Module 6 where we talk about advanced object-oriented programming. This is one of those things where a generic can be really anything unless we limit it, which we're not limiting it. So we're saying it can be anything, whether it's a string, an int, or your own model or something else. So load data, and we'll pass in our SQL statement, our U parameters, and then we also want to know a Boolean if this is a stored procedure. All right? We're going to probably want to know that. The only problem with this is I know that some databases don't use stored procedures. In fact, SQLite does not have stored procedures. So if I ask for it here, we later want to add another data access type, we're going to have this Boolean that means nothing to that database type. So I really don't want to ask for that. So I'm going to leave that off. We're going to figure out a different way of determining if we're using a stored procedure or not. All right, so now I have my SQL statement and my parameters. I have in here a using statement using IDB connection, control dot to add the system.data namespace, which I forgot to add. IDB connection, we'll call it connection equals new SQL connection. Control dot to add, or to install the package system.data.sql client. So here's one where this actually is a NuGet package we need to add. Now we could go to NuGet and search for system.data.sql client, install that package, come back over here, and add a using statement up here for using system.data.sql client. Or with our control dot, since it knows that's probably what you want, we can find and install the latest version. It's going to install that package, and it's going to add our using statement at the top here. Now I need to pass in a connection string. We don't have a connection string. We need to get one. Where do we get one from? Well, it could ask for it to be passed in, but we're going to use in this class library and in our user interfaces, we're going to use dependency injection. And we've talked about it a little bit, but I do want to cover this. I do want to put this in place. I debated doing this because this is a foundations series. It's not a super advanced series. However, dependency injection is really, really important to understand. And at its heart, it's actually pretty simple. The idea is that instead of us saying equals new for instantiating classes inside of our methods, we do that way back at the top at the user interface level, which we don't even have that yet. And we say, okay, when you create a SQL data access class, I want you to pass in the instances I need. That way we can change those out later. So we'll see this in action so you can kind of get your hands dirty a little bit using it. But let's start by creating a constructor. So CTOR. Remember, constructor is that method that's going to run whenever you instantiate the SQL data access class. And in here, I want a I configuration, which control dot, I have to install the package microsoft.extensions.configuration.abstractions. If I install the latest version of that. I'm going to call this config, and then do a control dot to create and initialize the field _config. So we have a private read-only I configuration, and that's called _config. And we're putting the value of config into _config. And the reason why is because this variable only lasts as long as the constructor does. And the constructor goes away right here. Therefore, if you want to save it long term, we have to put it into a variable that lasts longer than that. In this case, a variable that lasts the lifetime of this class instance. Now it's read only because once we write to this, once we save this value, then we don't have to change this config anymore. We're asking for an instance, we're getting it, and now we're saying you don't need to change that instance or overwrite that instance. You can use it, just don't overwrite it. And you wouldn't want to because we're not going to instantiate it or reinstantiate it with something else. So it's read only. Now, some people have asked about the underscore. The underscore indicates basically that this is a property you should, or a variable you should not access directly or should not overwrite directly. So we shouldn't write to this directly. You can read from it, but we don't want to write to it. All right, so that's the config. Now that we have this, and this is going to come from dependency injection. So our user interface will say, oh, you need an I configuration. I'll give you one of those. Which one? Don't know, don't care. So now down here in our method, we can say string connection string equals _config.get connection string. And which connection string do you want to get? Now this is something we have to pass in. So we're going to have to pass in string connection string name. So is this default? Is it something else? That's what we're going to have to figure out. But this will then read that value from our app-settings.json file, which again, we don't have that yet. But that'll be in the user interface. That way, the user interface can say, I want to use this SQL connection string. Maybe we have a different connection string for our web app than we do for our WPF app. Now, that probably doesn't make sense, but there's a possibility. But this way, we're allowing that to change at runtime. So if you install the WPF app on the server in Hotel A, they'll have one connection string. But if you go to Hotel B, it'll have a different connection string because it's a different SQL database. So now we have a SQL connection, or a SQL connection string. We can pass that into our SQL connection. Now, and this is the same code we did pretty much in the in module 8, we can say a list of type T equals, rows equals connection.query type T, SQL statement, parameters to list. Okay, and then return rows. So what are we doing here? We are creating we're using our connection, and we're saying query. A query in Dapper means we're returning data. Execute means we're running a SQL statement, but not returning a whole data set. We may return a value, but not a whole data set. So query, and we're passing in the type T. What is this type T? Well, this is the model that we'll use to get each row. So each row will fit into one of these models, and therefore we'll have a list of them to return back. That's our rows. There's our select from or insert into. Well, the query is probably select from, or our store procedure. And then here's our parameters. For example, if we're limiting our query in some way, maybe the start and end date will pass in or something like that. That's our parameters, which is of type U, meaning it can be any type you want. Most likely we'll create a new anonymous class, but it may be we pass in a model, which has all the properties. Either way, that gets us our list of rows of type T, but it returns an IEnumerable. We want a list, therefore we say to list. That gets us our list of T of type of rows. We return rows. Now we have all the data from SQL. We're almost done. But remember I said that we want to be able to identify if this SQL statement is a stored procedure. A stored procedure is a type of SQL object. We don't have one yet, but if we had one, it's a different call. And so that's a query. So instead of doing a select star from in your code, you can say call this store procedure, which inside of it has your select from. The benefit of calling a store procedure is that SQL can optimize that call. We can more easily identify what that call was, and it's also something where you can put multiple steps of logic inside of one procedure and have it all done on SQL side. So we want to be able to allow for store procedures, but how do we check to see if this is a store procedure? Well, a store procedure typically starts with DBO dot. And that's because that's the namespace. That's the most common namespace. However, not all namespaces are DBO dot. So we can't do that. Because if it starts off DBO.sp users underscore lookup, it would seem obvious we can just look for the first 4 characters being DBO dot. But what if the namespace was something like sales instead of DBO, which is possible? Well, now we're saying that's not a store procedure. So that's not right. We could try looking up by certain SQL keywords and see if we find a select. But what about insert queries? We could look for a select or an insert. Yeah, what about update queries? Well, now we're looking for update. What about merge? Okay, now you got merge. What about delete? Okay, so you have this whole long list of possible values, plus the fact that what if your store procedure was dbo.sp users underscore delete? Well, if you're looking for delete and you find it right there, then that's not a store procedure? Well, that's not right. So I don't think that we can accurately identify just by the SQL string whether it's a store procedure or not. So I think we do have to indicate in some way that this is a store procedure. But at the same time, we can't really just say, add a parameter here for store procedures, because that doesn't make sense. But with other database types, do you think it's possible we may need additional information that's not a part of the normal call? Well, maybe. And so I think in that case, what we need to do is do something like this, where you say dynamic, and then pass in options, or give it a name of options. Now, a dynamic object, we're using U typically as a dynamic object, where it could be basically an anonymous class. What that allows us to do is it allows us to have options that may be different for SQL versus SQLite versus MongoDB. So let's right-click and say refactor, and we're going to add a wrap all parameters. That makes it a little more easy to read. So now you have 4 options or 4 parameters to pass in: the SQL statement, the parameters, the connection string name, and options. And or we could say command type dot store procedure. Well, this is a command type. So if we say command type and just call it command type equals command type dot text by default. All right. So that would mean we could then say pass in command type, that variable, not the name. All right. So now we're passing in that variable, which right now is just set to text, the default. But we can say if, and our options dot, and here we specify is stored procedure. Exist. If it doesn't exist, then we obviously aren't saying it's a true. It's not a stored procedure. So if it's not null and the property is true, okay? So if it is null, we don't even do this check. So therefore, we won't have an exception here trying to check for a property that does not exist. So if it's not null and the stored procedure is true, then set to type stored procedure. So now it's going to be text by default, but if this is true, then make it a stored procedure instead, and that changes our command type. So now we have the flexibility of having either a stored procedure or just a regular SQL statement, a select star from or insert into or whatever. So there's our load data method. Now let's create another one. Public void save data of type T, string SQL statement, T parameters, string connection string name, and then dynamic options equals null. And again, after we add the curly braces here, we're going to right click and quick action refactor to wrap every parameter like so. All right. So now we have every parameter wrapped, and we can do pretty much the same thing as what we have here. So let's copy it and paste it. This is a time-saving thing because of video. This is not something I encourage you to do because there's a lot to change now. All right, return, don't have that. So we need to get rid of that row. So shift delete and deletes the entire row. The return statement here, or the capture, don't do that. ToList, don't do that. All right, query, nope, it's execute. And it's not a type T. All right. Otherwise, I think that's all. We're getting the connection string, review every line since you've copied and pasted. So we've got the connection string. We're setting the default type to be text, but if it's a stored procedure, set it to stored procedure. We're opening a connection to SQL. We're executing our SQL statement, passing in our parameters and our command type. That's correct. That's all we have to do for save data. So now we have this little class that's going to load and save data. There's a lot of little stuff here in this class. And you don't want to redo this every time you talk to SQL. So you do it once, and then we just call load data or save data whenever we need to. I've talked multiple times in the course of this series on dry. Don't repeat yourself. This is one of those cases where we don't want to repeat ourselves. Even if it was just these lines of code right here that repeated. We don't want to repeat that. We want to be able to do it once and then not have to repeat that over and over. Do it once and then call the method over and over. So that's what we're going to do with this load data and save data. And that's all we need to do for our Dapper class. Okay? Yes, it is a little bit of kind of semi-advanced code, and maybe it's something you're struggling with. We've already seen this a few times, but it can be difficult at times to work with this type of code because it is a little more advanced. So if you're still not getting it, don't worry. It'll click. Just give it time. We're going to use this. So worry about just using it and how you use it. And then keep coming back and trying again, figuring out what it does. Maybe step through the code. Give it time, and it will eventually come. It's just going to take time and practice. Those are the two really important pieces of learning advanced C#. Okay? So now we have our data access class. The last thing I want to do is I want to create an interface. And the reason why is because I'm going to want this class in other classes. I want an instance of this class. Therefore, I want to instantiate it. We don't want to instantiate classes by saying equals new SQL data access. Instead, we want to use dependency injection. And the way to do that right is through an interface, because that way we can swap out our SQL data access for SQLite data access or MongoDB data access. So I can right click and say quick actions and refactoring. I've selected my class here. And it says extract interface. And so it's extracting interface, and it says, okay, what do you want to extract? In this case, my two public methods are load data and save data. And I'm going to call this iDataAccess, not iSQL data access. That way, I can have other data access classes also use this interface. We're going to create a new file called iDataAccess, and it will be in the same directory as our databases. So we hit OK, and now it's applied that interface, and the interface is these two entries. Okay, now it says system.collection.generic. Let's do this. Get rid of that. Control dot, add a using statement. All right, and they are quite long, so let's do this. Let's also wrap these. So quick action refactor. Wrap every parameter, and let's wrap aligned parameters. I'll do the same thing for this one as well. All right, so there's our two entries in our interface. Makes it a little easier to read that way. Okay, so now we can access this class via the iDataAccess and not wonder or not have to know what database type we're talking to. We're just going to say, hey, we're going to talk this way. Now, as I'm thinking about this, I'm thinking, you know what? we might need to know because stored procedures. Not everything uses stored procedures. Therefore, we have to know if we're using SQL or not. So I'm actually going to delete this interface and start over. This is the easiest way of doing this. I deleted it and got rid of it. Now I'm going to do it over again. We're going to go one level higher for our generic interface. So extract interface, and we're going to leave everything the same. So it's going to be iSQL data access. Everything else is the same. We hit OK. And now we'll have a different one called iSQLite data access. Be a little bit different, and that's OK. Which does mean we might be able to change this from dynamic to something like a Boolean. I kind of like that idea. Okay, this kind of refactoring, it should happen as you're building it. Because if you have better ideas, don't wait until it's too late. And I think this is a better idea since I've now said I'm going to create a specific interface for every database type. And then one level higher in the data folder is where I'll have the generic interface. So therefore, I'm going to say, instead of this, it's going to say bool is stored procedure. Okay? And by default, it's false. So now we're going to say if is stored procedure equals true, and that's a lowercase I, then make it a stored procedure. Okay? Makes it a little simpler. Not as much checking to do. I can do the same thing. Actually, let's copy this right here. I can do the same thing for my save data. And then down here, I have to just change this to be lowercase I, but is stored procedure equals true. And that makes my code a little easier. But now I've got this red squiggly for my interface. So I have to come over to my interface and, oops, now I have to redo this since I've made some changes. So control dot to add the using statement. And then let's quick action refactor to wrap every parameter. And this last one, instead of dynamic options, that should be bool is stored procedure equals false. Let's wrap these parameters. And then let's set this to be that same bool is stored procedure equals false. All right, there we go. Makes it a little simpler, and yet it still is going to work for our various database types. Okay, so that's all set. Now we have our Dapper data access layer, and I'm a little more comfortable with that. I like it a little better. We've made some tweaks and changes from what we had before. And now we're ready to move on to the next lesson. Okay, so once you've played around with this, made sure that you understand what's going on, tried it, typing it back out yourself, go ahead and move on to the next lesson.